In this video, I'm going to discuss how to find resultant of two vectors quantity. For this, we use a law called Law of Parallelogram. Law of Parallelogram. And what is Law of Parallelogram? Let us say there are two vectors, vector P and vector Q, inclined at angle theta, and we wish to find resultant of these two vector quantity. For example, say there are two forces, F1 vector and F2 vector, are acting at a point at angle theta, and we want to find the resultant force. Okay, so for that we use law of parallelogram. Okay, again I redraw it. Say this is vector P. Let me represent with the OA. So what is OA? It's a vector P. Say this is OB, which is vector Q. These two vectors are inclined at angle theta, and we wish to find resultant of these two vectors. So first, try to make the parallelogram. Since AC is parallel to OB and in the same direction, so we can write this is also vector Q. Now, by the law of triangle, vector law of addition, law of vector addition, or that is triangle law of vector addition. Triangle law of vector addition, which says this is first vector, this is second vector. The resultant will be a line joining from the tail of the first vector to head of the second vector. So that will be the resultant. Let me represent with the R vector. So what is this R vector? Obviously this is sum of vector P and vector Q. So what is the law of parallelogram? We can write, given two vector P vector and Q vector inclined at angle theta, so their resultant will be the diagonal of the parallelogram formed by vector P and vector Q. This is law of parallelogram. Now, let's find its numerical value. Suppose if we want to find the resultant value, what will be the resultant in magnitude? So for that you can do, let's say, drop a perpendicular and produce this line. Drop a perpendicular, let's call this as line CD. We want OC, so you can see that OC square, by the Pythagoras law, OC square is equals to OD square plus it's a CD square. Okay, now if we get OD and CD, we can find OC, that is resultant R magnitude. Now if you see, because line OB is parallel to line AC, that means this angle will also be theta. See this angle theta, so this will be also theta. Now we want OD and CD. Okay, for OD and CD, see triangle CAD. In triangle CAD, we can write the cos theta to be equals to, it's a AD upon AC. So that means AD will equals to AC cos theta, or AD will equals to AC. And what is AC length? This is nothing but the magnitude of vector Q cos theta. So we get AD. Let's say equation 1. In the same way, in the same triangle CAD, the sine theta to be equals to, it's a CD upon AD. That means CD will equals to, it's a AD sine theta. CD is equals to, sorry, it's a AC sine theta. Sine theta here in the C in the diagram, the sine theta will be, it's a CD upon AC, not AD, it's a CD upon AC, right? So your CD will be, it's a AC, not AD, it's a AC sine theta. And again, see the CD, that is AC. AC is nothing but magnitude Q sine theta. Let us say this is equation number 2. So by this we found AD and we also get CD. So here that OD could be written as, it's a OA plus AD, where OA is its magnitude of vector P, and AD by the first equation we can write it's a magnitude of Q cos theta. So we get that OD. The same way we know the CD. So again using this equation OC, what is OC? You see this is nothing but the resultant R magnitude, which is equals to OD square. So OD square will be, it's a mod P plus mod Q cos theta whole square, plus CD, where CD is mod Q sine theta whole square, and this is magnitude R square. Now simplify this. On simplifying, we get that R vector magnitude square is equals to mod of P square plus mod of Q square cos square theta plus 2 times of mod P mod Q cos theta plus this is mod Q square sine square theta. See this and this, if we take it out Q square common, that means could be written as magnitude of R square is equals to, this is P square, if you take it out Q square magnitude common, it is cos square theta plus sine square theta, which is going to be 1 plus 2 times of mod P mod Q cos theta, which means this is resultant of R vector magnitude comes out to be, it's a square root of, it's a mod of P square plus mod of Q square plus 2 times of mod P mod Q into cos theta. And that's an important relation, and this is called the law of parallelogram. The resultant of the two vector P and Q inclined at angle theta is given by square root of mod P square plus mod of Q square plus 2 mod P mod Q cos theta, where theta be the angle between vector P and vector Q. Okay, suppose now if we want the angle the resultant vector makes with vector P, let's call this angle is phi, and we wish to calculate the angle phi. What is phi? It's the angle resultant vector makes with the vector P. So you can see in the diagram that tan phi, see the tan phi will equals to, it's a CD upon OD. Okay, so I'm just using this, the resultant, that is tan phi. The tan phi, see in the diagram, that was it, that is it's a CD over OD. CD earlier we have find CD, this will be mod Q sine theta over OD. What is OD? OD is OA plus AD, where OA is magnitude of P plus it's a mod of Q cos theta. So we get the tan phi equals to mod Q sine theta upon mod P plus mod Q cos theta. We can also write that so phi to be equals to tan inverse mod Q sine theta upon it's a mod P plus mod Q cos theta. This is the way how we write. So that's the way how we get the resultant of two vectors, and this is complete law of parallelogram. Now let's consider one example. Say in a question is given as there are two forces F1 and F2 at angle 60 degree. Magnitude of each force, that's a F1 magnitude, F2 magnitude, is equals to, let us say it's a 10 Newton. My question is find resultant force. Find resultant force. So we'll use the law of parallelogram. Let me say, if I make this is a vector F1, this is a vector F2, no problem, you can take F2 to be here, F1 could be here, so there's no issue. So this angle is 60 degree. Let's make the parallelogram. This will be the parallelogram, so that this is what, it's a F2 vector. This angle will be what, it's a 60 degree, and that will be the resultant R. Of course, here resultant R will be, you can say it's a F1 vector plus F2 vector. Now we want the magnitude of the resultant vector. By the earlier law, we can say the resultant will be equals to magnitude of F1 square plus F2 square plus 2 times of F1 F2 cos theta. Sometimes we say F1 mod square. You can also say it's a simply F1 square plus F2 square plus 2 F1 F2 cos theta. No, not necessarily to be say every time modulus. Okay, which is equals to, it's a 10 square plus 10 square plus 2 into 10 into 10 into cos 60, which is 1 by 2 cancel out, which is 10 root 3 Newton, which is 10 root 3 Newton. So the resultant will be 10 root 3 Newton. Now we want what will be the angle. It's a symmetry, because these two forces are same. You can check that this angle, resultant angle, will be in between, that will be 30 degree. But let's find mathematically. So by using that relation, that 10 phi, instead of Q, here it is F2 mod sine 60 over, it's a F1 magnitude plus F2 cos 60, which is 10 into root 3 by 2 upon 10 plus 10 into 1 by 2. This is 15. So comes out to be 1 by root 3. So we'll write that 10 phi to be equals to 1 by root 3. That means phi will equals to, it's a 10 inverse 1 upon root 3. If we know the value of this, 10 inverse 1 upon root 3. So for what angle the 10 value is 1 upon root 3. So here we know for angle 30 degree. So that means 10 inverse 1 upon root 3. That means we can strictly say this is equals to, it's a 30 degree. If you don't know the value, you can also say that phi to be equals to 10 inverse 1 upon root 3. That will be also correct. So this will be your law of parallelogram.